Hey, what's up guys? On today's video, we are going to talk about race condition in Go programming language. So first of all, let's look at the definition here. It says like a race condition definition, and it's a race condition occurs when two Go routines access a shared variable concurrently. At least one of the accesses is a right. So basically, it's like if we have a variable, right, like a global variable, and there are Go routine try to modify the variable, and it's gonna cause a problem because like Go routine, like two or more Go routine, they might run at the same time, and if you try to modify it, and it's gonna cause the problem. So in this video, we are mainly gonna explain it, and we're gonna show you some examples, and we're gonna find some, gonna show you some solutions for this rate condition problem. So first of all, let's look at this very simple. Let's say we have two functions. We got a deposit and the balance. It's like we have a bank, right? We have a balance. Or like a bank account, we have a balance. We can deposit our money to the bank, and we can check the balance. So, for instance, if we have two people try to save money to one bank account here. So let's say we have Alice and we have a Bob. And Alex deposit $200, and Bob deposit $100 to the account, and the balance should be like 300, and they are like doing like a simultaneously, and so we have that's the reason why we have two Go routine, and they're gonna work concurrently. Like you can think of they doing at the same time at two different places. So the result gonna be let's see the procedures here. So we can think of if we run the program here. There's like four possible results. So the first of all is that Alice it read and the deposit. It read the balance and put the added amount and return a new balance. So it says Alice first done the deposit, and then Bob done the deposit, and then balance is like 300 here. Yeah, that's cool. That's correct. And it could be because they running at the same time, right? It could be this Go routine run first. So it's going to be Bob deposit first, then Alice deposit first, then we can get the correct balance as well, 300. And the third possible result is Alice, Bob, then Alice. It's like Alice try to before Alice deposit, right? If you look at this function here, before we do the deposit, we need to read the current balance, right? So if read the current balance, and before they do add the amount to the balance, and Bob gonna deposit. So when Bob gonna deposit, right? And when Bob done the deposit, then Alice done. After Bob done the deposit, Alice done the deposit, and we can get the same result of 300 balance, which is cool. And the fourth possible, the fourth one is that's the tricky one. It's gonna get incorrect balance. So let me just explain that to you. So basically, Alice read the balance from beginning. Alice read the balance is 0. Then Bob deposit 100. After the Bob done the deposit, then Alice deposit 200. Cause when Alice done doing the deposit, right, their balance is 0. Then add 200 to the balance. So result going to be balance, because this balance is 0, because in this go routine, in Alice's go routine here, it doesn't know that Bob has deposited 100 in there already, because they are running at same time, and Alice, this go routine, it didn't update, it didn't get the latest balance, which is deposited by Bob, and it's still using the old one, and then deposit 200, then balance that returns to 200 there. So that's gonna cause the problem. That's very dangerous if we're doing like a very precise number thing, like a bank or financial. So that's gonna cause a problem. Although we don't often, if we run this code, right? Although we don't, it's not happening all the time. It maybe happen like a one time in 1,000 times, but this is a really serious problem. So this is the problem. We call it like a race condition, because we have 2 or more go routine. They try to modify it. They try to update a variable, which is shared variable, and it gonna cause the problem. It cause the result is result is incorrect. So we have some solution to handle the race condition. The first of all is do not modify the variable. It's very obvious, because like the problem is we have like a more go routine try to modify a shared variable. That caused the problem. If we don't modify the variable, it will be not a problem, because it doesn't have anything in common. It's gonna be all independent. So the second way to handle race condition is avoid accessing the variable from multiple go routine. So if we have this variable in one individual go routine, and only one, maybe we can call that like a master go routine. Like only the master go routine can modify or update or change the variable. And others go routine, they can only receive the value that passed from master go routine. So they don't. So other like a worker go routine, they don't do modify or anything. They only receive. So when they do any modification, they're gonna pass the result to master go routine. Only the master go routine can modify the variable. So let me just give you examples here. So let's see the example here. Let me just comment this out. So what are we having here? So we have like 2 channels. One is called deposits, another one is called balance. So we have a function called deposit, and it take the amount, and it pass the amount to the deposit channel. And the balance function, it get the value, get the data from balance channel, and return the out. And we have a function called teller. This is like what we are talking about, like a master go routine, and that is the one that manage the variable, and they do modification and they do update to variable. And only this function or this go routine, they can modify it. Other go routine, they only to handle, they only send data, but they don't do modification. So we have an example. If we're gonna run this function called run bank, we have this is like a master go routine. It listens anything coming from channels. For example, if we have something coming from the deposit channel, and we take the money out, we're gonna add it to the balance. And if we and we send the balance to the balance channel as well here. So basically, this is master go routine that listens anything from channels. So in the channel, we only do like a 1 by 1. So that's what it says here. Avoid accessing variable from multiple go routines. So only one go routine that can handle the variables. So we can do it on this way. So if like this, we can get the balance. We call the balance, get the result, and we can do the deposit as well when we call this deposit 200. So workflow gonna be like 200 amount gonna go into the deposit channel, and it gonna assign to the variable called amount and add it to the balance. So it's like a pipeline, and we only have like a one go routine that take care of the variable. So that's second way to deal with race condition. And the third way, this is the main one that I want to talk about for this video, is allowed only one go routine to access variable at one time. So we need something to control the go routine. Only one go routine can access to the variable. Okay, so we have something called Mutex. It's called mutual exclusive. So let me show you the example here. So we have a built-in package called sync, and we have a Mutex. So we have a deposit here. I just name it a bank 1 deposit, and we have a get balance, like bank 1 balance. And what are we here? Like before we get bank, right? Or before we do get balance, or before we get balance, and we do deposit. Before we actually do the deposit here, we actually have a lock here. So when we have we start a Mutex lock here, right? So the Mutex lock that only one go routine to access the variable at one time. So that's what it says here. Only one go routine access the variable at one time. Even you have like a 10 times, like 100 of go routine try to get balance, right? So it's gonna queue up, and it's gonna in the queue. So we're gonna do that 1 by 1. The next go routine can access only the previous one get unlocked. This is like a before, like when you run this deposit or the balance, right? When you call this function, and we add the lock. So when we add the lock, right, and the other go routine try to run this function, but it got locked here, so they can't actually carry on. They have to queue. So until the previous one get unlocked, then second one can get into to get the value or modify the value. So this is very important, that for like so basically we make it like without the lock, it's like a concurrency, right? And like if we put on the lock, so it's going to be like only one go routine to can access the variable. Okay, if we, let me see if I can run this. Okay, that's bank 1, and we have like a deposit here, and we get the balance after 2 deposit, and we get balance. Let's see. It's gonna take a bit long, little time, because we have set like a 10 millions of like loop to get balance here. We got more concurrently reads. Oops. So we have get final balance here, and as you can see, because it takes like a 3 seconds or something, right? Because we have like a balance, we have there's like a 10 million time of call this function called bank 1 balance. It get balance like for 10 million time, because this is like a because we do it like 1 by 1, right? So we have the like 10 millions of this get balance function is queued up. So you have to wait for previous one to finish, then they can carry on for next one. So what we can do is that we can optimize it by have a rewrite mutex. So let's move on to optimize this function. So we have something. Oops. So we have something similar compared to previous one, apart from here. So previous one we having a lock called sync.Mutex, and then on second one here we have rewrite mutex. Here it's a rewrite mutex. So we have a rewrite mutex lock. So this is like a rewrite mutex lock. That's same as previous one. So on here we instead have a lock, we have like a relock. We have relock. So for relock, they don't actually block it. So we have that similar. This is like a 10 million time here, and so basically we just change the lock. We change the lock, normal lock, to rewrite lock. And on the rewrite lock we call like a relock here. So for reading you don't need to queue, right? And even you run like a 10 million time, it's still gonna be faster than lock, because if you do lock, right, it's gonna be like you need to do that 1 by 1. So if we're gonna run that, let's see. So we have bank 1 and the bank 2. Let's say. So if we run that again, and we should be able to see the bank 2 is like more faster than bank 1, as you can see the results here. And if you have like we have testing like with 10 million, if you check that with like a more loop, you can see the time will be like have more gaps. Okay, that's it for today's video for race condition. I hope you guys enjoyed this video. I'll see you guys on next time. Bye for now.